In this example, it says a claim is that the cost of men's athletic shoes is less than $80. The sample of 36 shoes determines that the average is $75 with a sample standard deviation of $19.20. Should the claim be rejected at alpha equal to 0.10? So once again, we're going to start off with this and realize this is the area of the tail or tails, depending on which type of scenario we have, if it's one or two tails. It says here the claim is that the cost of men's athletic shoes is less than. Okay, so that's important. So this is telling us that there's going to be direction. Okay, so step one is to state the hypotheses. In this case here, we have H0 and H1, and it's saying is less than $80. So we can say the mean is less than $80. That means that the null hypothesis is greater than or equal to $80. And based on this, this is telling us that it is going to be one tail. And in fact, let's just go straight to the point here. This is going to be a left tail. All right, because it's pointing to the left, less than. So second is to find the critical values. Based on our information. And what does that look like? Once again, in terms of our picture, let's put our mean together, our normal curve with the mean in the center. And this time it's a left tail, so I'm going to put a left tail right here. I'll shade that in. And once again, pay attention to the detail because it's telling us that the tail is 0.1. So that's the area of the tail, which means we need to find the area between here and here. Well, once again, what do we use? Say 0.5 minus the tail is 0.4000. I'll use the 4 decimal places because we're going to go to our Z table and we're going to find what that Z value that's associated with 0.4000. So going to the Z table, and 0.400 is between here and here. Now, in this case here, I realize that in this case, the Z value is closer to 0.3997 is closer to 0.4, but it is preferable to go with the larger of the two values. Once again, this actually increases the standard of our test. So I'm going to use a value of 1.29. So I'm going to go with the larger of the two values. Now, putting that into our picture, what does that look like? The Z value is negative, because it's on the left side of the mean, 1.29, negative 1.29. Third thing we're going to do, once again, is perform the test. Perform the test, right? The Z test. In this case, once again, it's going to be Z is equal to our sample mean subtracted from the population mean, or what we are claiming to be the value. Standard deviation divided by square root of sample size. And from our question, we have the following. We have $75 was the sample mean, minus 80 divided by $19.20 all over the square root of 36. And that gives us a value of minus 5 on top, and then down below 3.2. And that gives us a Z value, or Z test value, of negative 1.5 0.625. And once again, we're going to round that and say that's approximately negative 1.56. That's 2 decimal places. So negative 1.56, where does that work out to be on our graph here, or on our normal curve? Negative 1.56 is actually right here somewhere. So that's our test value. Okay, and you can see when we make our decision, what is that telling us to do? Well, since it's in the critical region, we are going to reject H naught. So our decision is to reject H naught. Reject H naught. Okay, so let's go back and revisit. We're going to reject this claim. We're going to reject this, and we're not going to reject this claim. All right, we're rejecting this, and we're not going to reject that. So what is that really telling us then? It's telling us that the mean is actually less than $80. Okay, so it's less than $80. So let's put a final statement together. And it looks something like this. Our sample data indicates the population mean cost of men's athletic shoes is significantly less than $80. So once again, you see that the 5 steps are pretty straightforward in terms of putting it together. And once again, we have to make sure that we get our hypotheses put together properly, because if these are incorrect, then that would affect your critical value, which means that when we perform our test, there's a possibility that we get the test value in the wrong region, and we might end up not rejecting H naught when we should. Okay, so in this case here, once again, this value is the probability that we actually made the wrong decision. Okay, and that's in this case 10%. So when it comes to hypothesis testing, there are different levels of significance, right? So we would actually determine the level of significance first and then do our test in order to keep our research valid. If you were to do the test and then fudge the value for the alpha, like the probability of having a type 1 error, then that would not be correct. Okay, so we actually decide how we're going to do the test, and then we take care of the actual steps and make our conclusion based on our initial conditions. With that said, I'm going to pause, and if you have any questions, make sure to reach out. I think these 3 examples should be enough to kind of get the idea across, and it is very systematic, so make sure that you follow the very systematic approach that I've used, and you shouldn't have any issues. With that said, have fun with the homework.